Before I get too far into invested in finding the volume of a solid using cross sections, what I need to do first is remind you of some geometric formulas. And that's because here's the thing. In order to find the volume of this shape we've sliced into pieces, I need to be able to find the area of the pieces first of these simple geometric shapes and then put them all together into the volume. So here's the thing. What I'm going to do is just go over the geometric formulas real fast, maybe give you a quick explanation of them, and then we'll talk about how to find volume in a second. So first and foremost, a square. The area formula for a square is S, or the side length squared. Now, fun fact for you, when we talk about the history of mathematics, multiplication actually derived from the geometric formula for area. And so this operation of squaring something came from finding the area of a square. That's why we actually call it S squared, because it's about the area of a square. Now, rectangles, hopefully you guys remember, is length times width. That's another important formula we need to know. I'm going to come back to the equilateral triangles because I have an explanation to go with it. Circles, hopefully you guys remember, are pi r squared, where r is the radius. That's an important one to know. I will warn you that in some cases we don't actually know what the radius is. Instead, we have the diameter. So I'm going to tweak this ever so slightly so it becomes the diameter. Remember that the radius is 1/2 of the diameter. And so what the area formula in using the diameter is going to become is pi over 4, because it's 1/2 squared, times the diameter squared. Now, let me repeat again. This formula is going to probably become more handy for us than the pi r squared formula, because more often than not, we're going to have the diameter and we're going to need to use it. The last one is a semicircle. Now, here's the thing about a semicircle. A circle is all the way around. A semicircle is only half of it. So that's what I'm going to do, is I'm just going to slice this formula in half. So if I have the radius, it's half of pi r squared. If I have the diameter, it's pi over 8 diameter squared. Okay, so those are important. Now, the other one, like I said, I was going to come back to was the equilateral triangle, and here's the reason why. I, as an adult, as a person who's done calculus for a long time, always have trouble remembering this formula because it's one that I don't use all that often. These are the ones I use for years teaching geometry, and so this one is the one that always eludes me. So here's what I'm going to do. I'm going to show you where the formula comes from before I write it. So here I have my equilateral triangle. Remember, equilateral triangle has all of these sides that are the same. Okay? So the other thing you should hopefully remember is that each of these angles are 60 degrees. That makes it an equilateral triangle. All the sides are the same, all the angles are the same. What I'm going to do to show you real fast is if I had just a plain old regular triangle, I know that the area formula is 1/2 of the base times the height. Okay? In this case, my base is this side length of S. Now, what I'm going to do real fast is find the height. So how I'm going to do that is slice it down the middle. What that becomes is a 30, 60, 90 right triangle. Okay? So that splits this into 1/2 of the side length each. Now, in case you have forgotten, you could use Pythagorean theorem on this, or I always teach my geometry kids special right triangles. So, if I know what this side is, the hypotenuse, which is this side, is going to be twice as big. Hopefully that makes sense to you. This is half the length of the side. That's the whole length of the side. And this height right here is actually this half of S times the square root of 3. Again, you can use Pythagorean theorem just to verify this real quickly. So it's the square root of 3 over 2 times S for my height. So I'm going to switch that out real fast. And I'm going to go ahead and combine things. So like 1 times the square root of 3, 2 times 2, S times S. And it gives me the geometric formula, the square root of 3 over 4 times S squared. So all I need to know is how long one of the sides of this equilateral triangle is, and I can find it from there. Because again, this is just a formula. Now, again, if you need to verify that's the square root of 3 over 2 using Pythagorean theorem, go for it. I would just switch out this S for a 1, and that would make things work out nicely. So I would use 1/2 squared plus x squared equals 1 squared. And that would give me my square root of 3 over 2. Hopefully that helps you understand where this formula came from a little bit better so that it's easier for you to memorize. Now, the other thing I want to go ahead and do while I'm at it is I want to go ahead and tell you how to calculate the volume using cross sections, okay? Here's the thing. If I know what the cross section's shape is, whether it's a square, a rectangle, an equilateral triangle, a circle, a semicircle, whatever, doesn't matter. Whatever shape it is, what we're going to do is we're going to integrate along the bounds using the area formula in terms of either x or y. Now, here's the thing. How do we know when to use x's and y's? Well, the answer is simple. It has to do when the cross section is perpendicular to one of those axes, okay? So if it is perpendicular to the x-axis, you use x as your variable. If it's perpendicular to the y-axis, you're going to use y as your variable. Now, it's going to start making more sense when we do some examples because, again, we're trying to combine geometric two-dimensional formulas into a three-dimensional explanation. So again, big thing here, make sure you pay attention to. The cross-section has to be perpendicular to that particular axis for me to use that variable. In case you forgot what the perpendicular symbol is, the perpendicular symbol looks like a capital upside down T. All right, again, going to come back and do some more examples, but here's the information for you.